Uh, yeah, so we're going to continue from the observer pattern. So we were on chapter 2 of Headfirst design. So yeah, 5 minute drama, a subject for observation. In today's kit, two possible bubble software developers encounter a real life headhunter. This is Ron. I'm looking for a Java development position. I've got 5 years of experience and oh yeah, and everybody else, baby, I'm putting you on my list of Java developers. Don't call me, I'll call you. Headhunter subject software developer. And this is a software developer. Hi, I'm Jill. I've written a lot of EGB systems. I'm interested in any job you've got with Java development. What are EGB systems? To write Java beans, systems uses outside Java components, EJBs, to build large-scale distributed transactional enterprise. Okay, beans. Okay, I'll add you to the list. You know, along with everyone else. Meanwhile, for Ran and Jill, life goes on, and if a job comes along, they'll get notified. After all, they are observers. Hey observers, there is a job opening down at Java beans are used. Jump on it. Don't blow it. Money in the bank. Thanks. I'll send my resume right over. This guy is a real job. Who needs it? I'm looking for my own job. Okay. You can take me off your list. I found my job. You'll answer on. Mark my words here. You'll never work in this town again. If I have anything to do with it, you're off my call list. 2 weeks later, Jill is loving life and no longer an observer. She's enjoying a nice fat signing bonus that she got because the company didn't have to pay her headhunter. But what has become of De'Aaron? We hear he's winning the headhunter at his own game. He's not still an observer. He's got on a call list now, and he's notifying his observers once a subject and observer all in one. The observer pattern defined. When you are trying to picture the observer pattern, a newspaper subscription service with its publishers and subscribers is a good way to visualize the pattern. In real world, however, you'll typically see the observer pattern dependent. Observer pattern defines a one-to-many dependency between objects so that when one object changes states, all of its dependents are notified and updated automatically. The observed pattern defines a one-to-many relationship between a set of objects. When the state of an object changes, all of its dependents are notified. So object that holds a state, and if the state changes, automatic update and notification to all the objects that are in the dependency list. And these are called observers. The subject and observers define a one-to-many relationship. The observers are dependent on the subject such that the subject's state changes. The observers get notified depending on the style of notification. The observers may also be updated with a new value. As you will discover, there are a few ways to implement the observer pattern, but once revolve around the class design that includes the subject and the observer interfaces. Let's take a look. The observer pattern define the class diagram. Here's the subject and the objects. We use this interface to register objects of the world and also to remove them from the observer. So we have a subject and we have register observer, remove observer, and notify observer. And then we have observers. For observer, we have an update. So each subject can have many observers. So we have an observer interface, uh, and yeah. So it has an update method, and then we have a concrete subject which has a register of all this stuff. That is basically a class that implements this. And I think it implements this. It basically is a direct relationship. Each subject can have many observers. Okay, and concrete observer. All potential observers need to implement the observer interface. The interface just has one method: update. Okay, so this is the observer interface, and this is the subject interface. Okay. Concrete observers can be any class that implements the observer interface. Each observer registers with a concrete subject to receive updates. So we have an updates and other observer specific methods. Okay. On the concrete subject may also have methods for setting and getting its state. More about this later. Cool. A concrete subject always implements the subject interface. In addition to register and remove the methods, the concrete implements a notify observers method that is used to update all the current observers when the state changes. So basically, a current observer depends upon the subject, where the state change. So we have a set state and a get state that implements this interface. Then we have an observer interface. A concrete subject implements subject. Okay. What does this have to do with one-to-many relationships? With observer pattern, the subject is object that contains the state and controllers. So there is a one subject with the state. The observers, on the other hand, use the state even if they don't own it. They are many observers and they rely on subject to tell them when its state changes. So there is a relationship between one subject to many observers because the subject is the sole owner of the data and the observers depend upon the subject to update them when the data changes. This leads to a cleaner over design than allowing many objects to control the same data. Or a loose couple. When two objects are loosely coupled, they can interact but have very little knowledge of each other. The observer pattern provides an object design when the subjects and observers are loosely coupled. The only thing that the subject knows about an observer is that it implements a certain interface, observer interface. It doesn't need to know how to print the class of the observer, but it does and there's nothing else about it. We can add new observers at any time because the only thing that the subject knows is the list of objects that implement the observer interface. We can add new observers when we want. In fact, we can replace any observer at runtime with another observer. The subject will keep going along. Likewise, we remove observers at any time. We never need to modify the subject to add new types of observers. Let's say we have a new filter class coming in that needs to be an observer. We don't need to make any changes to the subject to accommodate the new class type. All we have to do is to implement the observer interface in the new class and register an observer. The subject doesn't care. It will deliver the notifications to any object that implements the observer interface. We can reuse the subjects or observers independently of each other. If we have another use for a subject or an observer, we can easily reuse them because these two aren't identical. Changes to either of the subject or observer will not affect the other because those two are lively coupled. We are free to make the changes to either as long as the objects still meet their obligations to implement the subject and observer interfaces. Design principle. Strive for loosely coupled design between objects that interact. Loosely coupled systems allows us to build flexible over systems that can handle changes because they minimize the interdependency between the objects. Before we much higher schedule weather station, including the weather data class and its display elements. Okay, so we have a weather data class. Okay, weather data. And its display element make sure the diagram shows all the pieces fit together and also another developer might implement the display element. Okay. If you need a layer hub, read the text field, images or radio. Okay, so we will have a display interface and we have multiple displays. Display one, let's just say display two. All these implementing this in displays. Then we have a weather data. We have a probably display uses that. Now we have a cubicle conversation. So back to the weather station project, you see me already starting through the problem. So how are we going to build this thing? Yeah, let's just continue this in the next video. Thank you so much for watching.